How's it going, everybody? Today we're going to be talking about specific heat and how to calculate specific heat. So first off, what is specific heat?
Specific heat is a measure of how much energy it takes to raise the temperature of an object 1 degree.
Okay, so here it gives us 1 calorie is the amount of heat needed to raise 1 gram, which is 1 milliliter of water, to 1 degree Celsius. It also says that 1 calorie is the amount of heat needed to raise 1,000 grams, or 1 liter, of water to 1 degree Celsius. So again, we're just going to heat. It takes that much heat to raise the temperature for 1 gram of that. So let's go into each one for what exactly the formula is and how do we calculate specific heat. So let's go into the units first. The units are Q. Now what is Q?
Q is the amount of energy that is transferred. Heat is energy, remember, and so are calories. So Q stands for energy transferred, and the units are joules. We always use joules for energy.
Oh, there's 2 R's in there. Again, joules. Which when we use J for a unit of measurement, it's joules and not impulse like we've used before. So don't get those mixed up. Then we have M. What is our trusty M?
M is mass, the mass of the object that we're talking about.
And how do we measure that?
In kilograms.
Kilograms, which is kg. And then we have CP.
CP is the specific heat. That's a constant value for every object. Water has a specific amount of energy that it takes to raise the temperature. Milk has a different specific heat. Rocks have a different specific heat. It's just a constant value for whatever it is that you're talking about.
And we would measure that
in joules per kilogram degrees Celsius. It sounds kind of funny, but that's what it is.
And then finally, we're going to measure the change in temperature, which in trusty terms is just a delta T. So change in temperature, not lowercase t, sorry, it's going to be uppercase T, because that is temperature and not time.
Right.
Okay.
Our variables overlap a little bit.
So how do we find the change in temperature?
We take our final temperature minus our initial temperature. That's how we measure change in anything, right?
Right.
And it's always in degrees Celsius for temperature.
Which is temperature. Again, not lowercase, uppercase. Temperature final minus temperature initial equals your change. Okay, and measured in, again, degrees Celsius. All right. Practice problems. So the practice problem we have here says a blacksmith lowers a 3.2 kilogram of iron, which C equals 0.45 joules per grams degrees Celsius, at 130 degrees into water to cool. The final temperature of the iron is 45 degrees Celsius. How much heat was lost in the iron? So what's the first thing that we want to do?
We always write down what we know. We know the mass of the iron, so we're going to write that down first.
Okay, the mass equals 3.2 kilograms.
Right.
And it gives us C equals 0.45. And that was our CP, our specific heat, correct?
Yep. That's the constant value for the iron. That is the specific heat.
And that's 0.45, not 45, at 130 degrees into the water to cool, and that's degrees Celsius. So, again, we're going to measure the change in temperature, which is your temperature final and temperature initial. Would this be your final or your initial?
That's the initial. That's how hot it was at first, initially.
Okay, so this one is 130 degrees. The final temperature... Okay, so now we know temperature final equals 45 degrees Celsius. So what is the first thing that we want to do?
Well, we take a look at what we know, and then we choose the formula that we want to use. The formula that we're talking about is Q, which is the energy transfer, the amount of heat that was lost, that's what we're looking for, is equal to mass. So M times CP, that's the specific heat, times the change in your temperature, delta T.
Okay, so we need to find out what, so we have mass, we have our specific heat, and we have 2 different times. So we want to go ahead and find out what the difference is for that. We want to go ahead and find the change in the temperature. So we want to go ahead and we measure change again by taking our final and we subtract our initial, correct?
Yeah, that's right.
So we take our final, which is 45, and we subtract our initial. And that gives us
Negative 85
Okay.
degrees Celsius.
So temperature equals negative 85.
And the minus sign just means that the temperature went down,
Right.
which we know.
Okay, and then we have our mass times our specific heat. So specific heat was 0.45. And we have our mass, which is 3.2. And that gives us,
1.44.
so these two together would be 1.44, and we'll multiply that by negative 85, correct?
And that gives us a negative 122.4 joules.
And it's joules because it's going to be the energy transferred, correct?
Right. And it's negative because that was energy lost. That's energy that went out of the iron into the water. If it was positive, then that would mean that we had energy going into the iron, so the temperature would go up. But in this case, it went down, the energy went away, it was lost.
Okay. All right, guys. Well, that's it for us. We'll see y'all next time.